So when you want to approach a rational equation and you want to solve it, please do not multiply by the denominator because you potentially could be multiplying by a 0. Right? One of the values of the denominator could be a 0. And so what you do instead is, following Joseph's suggestion, you are going to make one side equal to a 0 by bringing everything to the other side. And all of a sudden, you have grade 11 math again. Y'all remember the very first unit in grade 11 math that set you apart? When you realized that this was truly grade 11 and not just regular math? What was the first unit in grade 11 math? Rational expressions, that's right. Okay, one of the things you did for rational expressions, do you remember? It was like some kind of bracket over some kind of bracket multiplied by some kind of bracket over some bracket, and then you have to, try to reduce it, and you make all the restrictions. It's basically that. So if you were not able to do that very successfully in grade 11, here's another chance. Okay. Let's approach it. Let's approach it calmly. How do you subtract or how do you add fractions? So we're going to do that. So this would be and I don't like to write the 0 every single time. So I'm just going to do this and make it equal, equal, equal. I actually would prefer to do this on the board, but because I write over here. You know what? Okay, and I'm going to just do this in one big shot. Okay. So that's the hardest part, in my opinion. The rest is just answering the question. So what was the original question? Solve it. Joseph, finish it off? Yeah. Yeah. So we need a numerator. So if we want 4 over 3x minus 5 to equal a 4, and we need 4 over 3x minus 5 minus a 4 to equal a 0. Well, when will this equal a 0? It's the same as saying, when will this equal a 0? When will that equal a 0 is when the numerator equals a 0. There. So this statement, therefore, is true when x equals a 2. That's solving an equation. Pardon? I'll say it one more time. So the question was, when is this statement true? Right? So the question said, when is 4 over 3x minus 5 equal to 4? That's the same as saying, when is 4 over 3x minus 5 minus a 4 equal to 0? Which is the same as saying, when is 4 minus 12x plus 20 over 3x minus 5 equal to 0? You see it? So when is this fraction ever equal to 0? When the numerator equals to 0. What I'm trying to get at here is, I guess, I should have maybe started with this. Answering this question is too hard. Right? Just on its own. Well, I guess you can guess and check. You can take a look at it and be like, hey, doesn't that just mean the denominator has to be a 1? You can say that. But you won't be able to say that solution for examples that are harder. And so I'm intentionally showing you what you ought to do, because sometimes directly answering it is too hard. So you are going to turn whatever equation into a single fraction to make life easy for yourself. Yes, Mason.
So the only reason you need to worry about the numerator is because
you're turning it into one fraction. Okay. You'll see what I mean in the next example. Does anyone need more time for this? Anyone? Yep, go for it. Yep.
What are the while moving 4 over 3, 4, because multiplied it by 3x minus 5 over 3x minus 5.
Right. So in the beginning, I was asking who would have multiplied 3x minus 5. Technically, you could, but that is up to grade 11 because 3x minus 5 being a denominator, it still has the potential of being a 0. We don't know that. We don't know it yet. All we know right now is 3x minus 5 is just a binomial, it's a polynomial. And so multiplying it will turn into 4 equals 4 over 3x minus 5. For now, it works. But there may be situations, very rarely, there may be situations where you accidentally end up multiplying with a 0. And when you multiply with a 0, you can either get something like 4 equals 4, which doesn't tell you anything. It doesn't tell you the x value. Multiplying or dividing by a 0 also can make this true. And so you don't want that unnecessary complex danger. So I would recommend you turning everything into a single fraction, bring everything to one side first. So here we go. Example 2. A little bit more annoying, but that's okay. And remember, I am going to move everything to one side as before. And then I'm going to see if you can use your grade 11 skills to figure out how to approach this question. Here's your question. You need to solve it. Can you solve this directly? Unless you are a human calculator, you cannot, right? A human computer, you cannot. And therefore, the greatest strategy you can employ is to turn this into one fraction, because if you have one fraction, all you have to do is look at the numerator and make that equal to a 0. So try it. How are you going to subtract these fractions? Yep. Yeah, and that's annoying. What did you do in grade 11? There's a reason why we did rational expressions first. How do you, yep. Factor it first, exactly. See which ones are common, which binomials are common. So if I factor this, this becomes x minus 4, x plus 1 over x minus 5 minus x plus 1 and x minus 1 over 3x plus 2. Yay, we have something in common. Actually, I'm going to take this and I'm going to switch places. Ooh. Just so that the blues are both on the right side. Why do I do that? so that you might be able to follow the next line. So the left fraction needs a x minus 1. The right fraction needs x minus 4. So I'm going to see if I can color coordinate that for you. But if you understand where I'm going, try it. Oops. Oh, and if you want to use color to draw your attention, I highly recommend it. I was never a person to use much color throughout my entire education. I'm talking under university as well. But once I started teaching, I realized how useful it could be. So sad. I need another color, maybe a green. There. So again, just to draw your attention, we got green and blue, red and blue. Now we have all three colors with all three colors. And you'll see that I'm trying to color coordinate. The left side, there were no red. So I have to have red on the top and bottom. On the right side, I had no green. I need green on the top and bottom. The rest is just calculate. I'm going to ask you to try it because you have more space than I do. And I'm going to do some mental math and tell you that the final answer should be this, or final result should be this. Go ahead and try it. See if you get the right answer. X squared minus 3x minus 6. 6. And then 5 minus 8 plus 8, I can say. There. Six, 4. I'll just give it another minute, okay? Oops. Oh, I cannot see anything if I do that. Okay, never mind. Never mind. Pictures. Okay, any questions? Everyone's okay with that? Yeah, simplifying is easy enough. I'm not sure if I gave you too much time, but from here, remember the original question was, when is that equal to a 0? Which means, therefore, when is this ever going to equal a 0? Can you factor it? It's not factorable. Does that mean it's never going to be a 0? Yusuf, how do you know? What can you do? Pardon? Quadratic formula. Absolutely. So right, you can confirm if it's not factorable, you have to check at the very last. Okay. So I'm going to check by factor theorem. By quadratic formula. Let's just do the discriminant to see if it even exists. So the discriminant of the quadratic formula is b squared minus 4 times a times c. Well, that's going to be a positive number. Well, that sucks. That means it exists. Anyone? So it's what? 4 times 2 times 120? So that means if this entire fraction is to equal a 0, is it 108? 4 times 2 times 13 plus 16. No, I got 120. So x is going to be negative b, so negative 4 plus minus root 120 divided by 2a, so negative 4. 120 divided by 16. Okay. In other words, x is going to be, let's see, square root of 120 minus 4 divided by negative 4. Negative approximately 1.74 or 3.74 approximately. Therefore, this statement is true when x equals negative 1.74 or 3.74. So this big fraction on the left will equal the right side fraction on the right side if x happens to be these two numbers. Well, that's of course not accurate. For questions like that, I believe it will be proper form to actually leave it as this. Can you reduce it? Some people are just waiting for me to finish so they can take a break. Negative b
Negative b.
plus minus.
Why is it 50 over 50? I guess something different.
Am I doing something wrong?
We got 2 plus 30.
2 plus square root of 30 over 2. What do you have in the denominator? It'll be 2a. It'll be 2 times negative 2. The denominator should be a negative 4. Yes. I can barely hear you. Say that one more time.
Can we say like so therefore can we say this statement is true like x is equal plus the square root of 120 and minus the square root of 120? Can't the forces cancel?
That's not correct. The division. This entire thing comes first. In other words, if the division of 4 is going to be applied, it has to be applied to both. And this is what I did. If you divide -4 by -4, you get 1. And divide root 120 over -4, you get 15 over 2. (120 over 4 gives you 30. Root of 120 over 4 shouldn't give you the same answer. If you're thinking that root 20 over, oh boy, everyone, you can't get this twisted at this point. Root 120 over 4 doesn't mean this. Okay, here's a quick exponents lesson. If you have x squared, let's see. Okay, if you have x half multiplied by x to the power of half, what do you do when you're multiplying exponents or multiplying powers? No, exponents need to add. When you have x to the power of 1 over 2 times x to the power of 1 over 3, it's not easy to do. But if you work it out, you should get 1, 2, 3, 6, 6, 2, 6, 3, 6, 3, and 2. 5 over 6. Okay. Right now, the reason why I talk about this is because you can't simply, how do I approach this in a simple way without getting you confused? Let's just put it this way. When there is a number with a square root, that's the same as saying it is 120 to the power of a half. Okay, square root is like an exponent. The exponent comes before a division following dead mass. And so if you want this division to actually happen, you need to turn this into the same exponent. So what is 4 the same? What is 4 equivalent to if it's the power of half? Other way. 4 is the same as square root of 16. This is not the lesson that I wanted to do. You have to know this. Here, let me bring up whiteboard. This is really important, everyone. Okay. 8 divided by 4 is a 2, right? But square root of 8 divided by 4, I cannot do right now. I need to turn this into a situation where both have the same power, so same exponent. Very different. Okay. So even this, -4 divides by -4, giving you a 1. And then root 120 is divided by -4, which gives you this. And if you want to simplify it, it becomes that. When you divide that out, it becomes the square root of 7.5
Oh,
or 15 over 2. Very important. Please don't be tempted to just divide this just because they look nice. Okay. Please do not be tempted that after you do what, that you just divide these numbers and leave it as square root of 30. It is not the same. Josephine?
Want us to simplify like that, like a fraction, quadratic again, or do you want us to just whole thing?
Either leave it as 1 minus root 7.5 or leave it as 1 minus root 15 over 2. Both are okay.
I think that's like 1 minus root 3 over 2.
Oh, I see. No, go all the way if possible.
Thing. You know how I said I got 2 minus 30 over 2?
Okay.
It equals the same number.
Of course. Of course. But you didn't reduce it.
So the
2 plus minus root 30 over 2 is correct. It's the same as what I have here. It's the same thing. However, I would say this is not reduced. This is not simplified. That's all.
is that a 15 or 7?
That's 7.5. Do you see how you can still divide 2 with the 2? That's what I'm looking for. I would say having a fraction versus not having like an actual fraction. Sorry, having a rational versus having a rational inside the square root portion. I think it's debatable, I'm sure. I do think this is not as simple as that, in my opinion. This is reduced and this is not.
with this and the last name,
Yeah,
we get that marked up.
I would like this one. Reduce it completely. It seems to be a struggle to go from here to here. What's the reason?
Yeah.
Yeah.
You have to think the numbers. You have to think the
Well, to go from 120 to a 30, you still divided this by a 4. So you knew that if you're dividing this by a 2 and you're dividing this by a 2, it's the same as dividing by a root of 4. You're doing the same thing again. You divide the bottom by a 2, which gives you a 1, and you're dividing the top by a 4. It's the same thing. I'm not sure where the struggle is.
You have to make the denominator.
If possible, yeah. If possible, it's because this number happens to be a very nice division. You can get rid of the denominator. Oh, you can get rid of the denominator completely.
Yeah.
Right? That's all. That took a lot longer than expected. We'll stop here for a second.